Okay, hopefully I make it. I got a low battery and a low voice. It's slipping. I'm slipping. I'm falling apart. 6.2, we're going to start it. I'm going to make 3 different videos, I think, depending on time. First one's just an introduction. The simplified form for radicals. Property 1 for radicals. Whatever index I have when I'm multiplying things together underneath the radical is I just apply it to every single one of them. Just think that. Whatever number I have out here, my index, apply it to everything inside. So I can break it apart. Nth root of A times nth root of B. Same when I have a fraction, I do the same thing. Nth root of numerator, nth root of denominator. So you're thinking of these in chunks. That makes sense when we jump to example 2. I'll break it down all the way under the radical to start with, and then we'll start, shortcutting after that. 48. Well, maybe I'll do this. When you have a number, you want to think, can I get a perfect something out of it, whatever my index is? In this case, a square. It's a square root. Can I get a perfect square out of 48? I can. 16 is a perfect square. So I'm going to pull a 16. Say you have 50. If you have 50, you're going to say, well, 25 is a perfect square. I can pull that out. Whatever you have, 32, you can say, well, 16 is a perfect square. I'm going to pull that. You're always looking for a perfect square. 16 times 3. I can rewrite this as 16 times 3. X to the 4th. Can I get a perfect square out of that? I actually can. I can get x squared times x squared, and then y cubed, I can get a perfect square out of it, y squared. You still can apply your typical rule and think what's left over, or remainder, if you have a remainder. I have a 2 for an index. 4 divided by 2 is 2. Sure enough, I have 2 of them. Y cubed, well, 3 divided by 2 goes in one time, but it gives me 1 left over. There's my leftover. So what I'm doing is I'm taking the square root of 16 times the square root of 3 times the square root of x squared times the square root of x squared times the square root of y squared times the square root of y. Now, we're not going to do this whole process for every one of these, but hopefully this helps unlock the meaning for you. So I have a 4, I have an x, I have an x, I have a y. Those will all be gone. So I have 4x squared y. I'm left with square root of 3, square root of y. There's my answer. And that's how I do these. My battery's about to die. If it dies, you'll see me in part 2 of this section. Now, let me see if I can get the fraction. Example 4, square root of 12 over 6, part A. We break it down as square root of 4 times 3. I'm looking for perfect squares. In this case, I have a perfect square, 4. I can pull 2 out, 2 times square root of 3. Now I can deal with this and this. These are numbers, everything's multiplied. I can whittle these away and just leave my radical. So 2 goes into itself once, it goes into 6 3 times. Square root of 3 over 3, I leave it, I'm done. I can't do anything else with that. Square root of 3 doesn't have an exact value. So for part B, 5 times square root of 18 over 15. There's obviously different ways we could do this. Right now, I'm going to get rid of this just to make it easier and have square root of 18 over 3. I'm looking, square root of 18, do I have a perfect square? I do. Square root of 9 times 2. Square root of 9 is 3. There is no perfect square of 2. And that's all over 3. Now I can whittle those away and get square root of 2. I could have pulled my 3 out and multiplied 5 by 3 and gotten 15. But you might as well make things go away when you can. And that's it for the intro. And I'll see you for rationalizing the denominator in a little bit. I know you're looking forward to that. See you in a bit.